Okay, in this video, I'd like to introduce PySpark, also the concept of lazy computing. So I am going to do this in Databricks. I'm trying to find it in data. Here we go. I am, as I say, going to do this in Databricks. In theory, you can do this locally. Um, Distributed computing works locally because work can be distributed across the cores of your computer. Um, in practice, I found this difficult to do locally. Just giving my own experience, you know, this is this needs a Java environment, and I had Java installed and Python installed, and I could not make them interact the way they needed to interact. So what a uh, what a happy stroke of luck that there's a piece of software that is explicitly designed to make PySparks work well. If I were working locally, I would need to import this. And also, I would need something like this. You have to explicitly tell Python, all right, I'm ready to start using Spark. So this is starting a Spark session. Um, Databrick is designed to be used by Spark, so it's already there, and you don't need to start a Spark session, and I can just click that button and do an import. And I am importing some movie rating data as a Spark data frame. Um, I wish they could have come up with something better than that, because now we have Spark data frames and Panda data frames, and they are legitimately different types of objects. Like, if I print this, what do you think will happen? If this were a pandas data frame, it would display. A Sparks data frame does not display. Instead, print gives us a summary of some metadata. Other commands are more familiar. The columns method works pretty much as you'd expect. For example, the head method sort of works how you'd expect, but not quite. If we were working in pandas, this would give us the first 5 rows. For a Sparks data frame, it's going to give us only the first row, and it's going to give it to us as a row object, this kind of dictionary-esque thing. Pandas and Sparks are both inspired by SQL and relational databases. So a lot of operations in PySpark will look familiar. You've seen select and filter before. And there we go. And you'll have to gain familiarity with PySpark syntax as we go along in this class, but probably all of this looks, I hope, at least kind of familiar. We select the name and the year column. We do some filtering. We look at movies I gave a rating of greater than 3 to. We do some summarization of the data. But actually, behind the scenes, something very interesting is happening. And that is that none of these data sets have actually been created. So this is called lazy computation, or rather lazy evaluation. Because go back to this code. I mean, I've defined movie info, but I haven't done anything with it. So from a practical point of view, what's the difference between creating this data set and not creating this data set? I mean, there basically isn't one. So what happens instead is that Spark looks at this. It looks at what I say I want to do. It says, okay, the user wants to create this data frame. It will have two columns. One of them will be name, and that will be a string, and one of them will be year, and that will be an integer, but it hasn't created the data frame. And this is important because PySpark, again, is intended to work with really big data sets, like hundreds of terabytes of data. So if you if every time if you have a data set that's 100 terabytes and you do a bunch of transformations to it, and every one of those transformations is being saved into the memory, then before long, that 100 terabyte data set is going to turn into thousands of terabytes. So this is how Spark helps get around that. At this point, Spark has noted that I might want these data sets in the future. It's noted what the columns would be if it has to create the data set, but it hasn't created any data sets. In fact, it hasn't even imported any data sets yet. Okay, now I've added a line of code, year underscore summary dot show. And this is going to do what maybe you thought print would do earlier. This is going to show some data. And now Spark is no longer going to have a choice. When I press this arrow, Spark is going to scan through this code. It's going to get to this, and it's going to say, okay, well, if I'm going to show the data, I need to create the data. If I'm going to create the data from DF, I need to import DF. So now we're going to see something. Now Spark is going to import the data and actually create your summary and then show part of it. As we see. At this point in time, movie info hasn't been created because I haven't done anything with it, and movies enjoyed hasn't been created because I haven't done anything with it. And year summary has only partially been created. Because again, I mean, Spark is not perfectly optimized, but Spark will look at this and it will say, okay, show needs to display 20 rows. What's the least amount of data I can pull in to display 20 rows? And it will pull in as little data as it can to still do what I'm asking it to do. And that, again, is the idea of lazy evaluation. So commands in Spark are either lazy or eager. And the transformations are lazy and actions are eager. And what I mean by that, I gave these examples in the code. If Spark sees these, Spark will make a note of it. Spark will say, okay, the user wants to create a new data frame, or the user wants to change an existing data frame. But Spark isn't actually going to do that unless you give it a concrete reason to. Those concrete reasons are actions. So in our in our coding example, show was an action. For Spark to show part of a data frame, the data frame needs to exist. So these actions, until Spark sees an action, Spark won't do anything. Again, that code that I showed you, which I'll just copy and paste, none of this is actually happening. Once I do something with it, once I showed a data set, something had to happen. So actions kickstart the code, essentially.